In this video, we're going to be talking about graphing rational functions with holes. Okay, so when the numerator and denominator share a factor, so factor being like something like x plus 2 or something like that, and it cancels out because it's on the top and bottom, then that's what creates a hole in the graph. So instead of there being maybe like an asymptote there, since it gets canceled out, it's just a spot in the graph that doesn't exist instead of a line that it can't cross, which would be an asymptote. Okay, so what we do is we factor both top and bottom if needed, and find if they have any common factors and cancel them out, and find where the hole is. So that factor that cancels out, we'll set it equal to 0 and solve to find where that hole is. Okay. We're also going to find vertical asymptotes, which means on the simplified fraction, after we've canceled everything out, we'll set the denominator equal to 0 and solve. Horizontal asymptote on the simplified function, we'll use Bobo-Bot-Needs DC, and I've made a previous video that covers these asymptotes. Okay, so go find that video. I can link it in the description for you. Okay, and then we'll find the x-intercepts, which is the zeros of the simplified numerator, and then the y-intercept, in which we're going to let x equal 0 and solve. Okay, and we'll solve, and then we will find the hole by plugging in that x value into the simplified function. All right, that's a lot. Let's do a problem. So graph this rational function. Okay, so the first step, we're going to factor. Okay, on the top, it looks like I can factor out a -2. So if I factor out a -2, this becomes x minus 4. Think of it as dividing a -2. So I divide a -2 into this, then it cancels out to x, and if I divide 8 by -2, it becomes -4. On the bottom, we're going to factor that using the AC method. So 1 times 8 gives us 8, and 2 factors of 8 that multiply to get 8, but add to get -6. That's -4 and -2. So the bottom factors into x minus 4 and x minus 2. Okay. The one that cancels out is the x minus 4. So I'm going to go down here to where it says hole, and I'm going to say x minus 4 equals 0, which will give us x equals 4. So our hole is going to be located at x equals 4. We'll find the y value in a second. So I go ahead and I cancel that out, and I'm left with the function f of x is equal to -2 over x minus 2. Okay, so this is my simplified function. Okay, so vertical asymptote, set the bottom equal to 0 and solve. X minus 2 equals 0, so you get x equals 2. So we'll put an asymptote at 2. Okay, there's the asymptote. And then the horizontal asymptote, we use Bobo-Bot-Needs DC. The exponents on bottom are bigger since the top doesn't even have an x. So that's Bobo, which means that your asymptote is y equals 0. Bigger on bottom, you get 0 as an asymptote. So we will put this asymptote here. Okay, so there's our new grid. Okay, and then let's find the x-intercepts. We find x-intercepts by looking at the top and setting it equal to 0, but the numerator doesn't have an x in it. So when I set it equal to 0, you can't solve it. So we're going to say there's none, no x-intercepts. Y-intercepts, we're going to plug in 0 in place of x, so I'll get y equals, we're looking at this simplified fraction, -2 over 0 minus 2. Okay, I replace the y with the f of x there, and then it's -2 over -2, which is 1. Okay, so at 0 we have a y-intercept of 1, which is right here. Okay, so our y-intercept we find by, or excuse me, where I found our y-intercept. Our other points, we're just going to plug in some points on either side of this vertical asymptote. Okay, so I will make a little coordinate or make a little box here for our x and y. We'll come up with some points. Okay, so let's try maybe 2 numbers on the left side of this vertical asymptote and maybe 2 or 3 numbers on the right. Okay, we know we have a hole at x equals 4, so let's do that one first. So when I plug in a 4 into this function right here, I get -2 over 4 minus 2, which is -2 over 2, which is -1. So our hole in the graph happens at 4 comma -1. So 4 comma -1 right there is a hole in the graph. You could treat it just like a point, but there's no actual value there. Okay, so that's our first one. Let's try let's try an x equals 1. So if I plug a 1 in, then I will get f of 1 is equal to negative 2 over 1 minus 2, which is negative 2 over negative 1, which is 2. So that gives us a 2. That's the point 1, 2. So 1, 2. Okay, let's do one more. Let's do negative 1. So plug in a negative 1 over there, and I get f of negative 1 is equal to negative 2 over negative 1 minus 2, which is going to end up being 2/3. Okay, so 1 goes up about 2/3. Okay, so there's that part of the graph. I can go ahead and kind of sketch that out there. There we go. And we'll butt up against that asymptote, both of them, but I'm not going to pass either one of them. All right, let's look at the other side. Let's plug in 3 because it's the first number on the other side of that asymptote. So if I plug in a 3, f of 3, oh, I didn't finish writing this point over here. What was that? Plugged in a negative 1 and I got a 2/3. That's right. Okay. So I'm going to plug in a 3 and I plug that into the function. I get negative 2 over 3 minus 2. Okay, and that ends up being negative 2 because the bottom becomes a 1. Okay, negative 2. So this is point 3, negative 2. 3, negative 2 is right there. Let's do 5. That'll be our last point. So f of 5 is equal to negative 2 over 5 minus 2, which is negative 2 over 3, negative 2/3. So negative 2/3 is about right here. So that gives us enough that I can go ahead and sketch this graph. There's a hole there, and then I keep going. Okay, so there's that graph. Okay, in this problem, we've got a quadratic over a quadratic. So I'm going to go ahead and factor both the top and bottom. I can factor out a negative 2x on the top, so I'll put that out front. And then if I factor that out, this becomes x plus 3. Okay, and then I look at the bottom. 1 times 3 is 3. Two things that multiply to get 3, but add to get that middle term of 4. That's 3 and 1. So it's going to be x plus 3 and x plus 1. Okay, so the x plus 3 is the one that cancels out. So I'm going to put it down here on this. Set that equal to 0. So you get x equals negative 3. That's where our hole is going to be. We'll find that value later. Okay, so we'll go ahead and cancel that out. So it becomes negative 2x over x plus 1. Okay, that's my new simplified function. Now, vertical asymptote, set the bottom equal to 0. X plus 1 equals 0 gives us x equals negative 1. Go ahead and sketch that at negative 1. Okay, and then horizontal asymptote, the exponents are the same, right? This has an exponent of 1, and so does this, so I divide the coefficients. So that's negative 2 over 1, which is negative 2. So y equals negative 2 is our horizontal asymptote. So let's put another little dotted line here, and we have our new grid. Okay, x-intercept, we make y equals 0. For x-intercept, we just set the numerator equal to 0, excuse me. So negative 2x equals 0. So that gives us x equals 0. Okay, so the x-intercept can be found at x equals 0. So we will cross right here at 0. Okay, so that's 1 point over there. Y-intercept, we're going to set the whole thing equal to 0. So I'll set this whole thing. Let me do it up here. So y-intercept, let me label that. I will plug in 0 for all the x's. Okay, so it'll be y is equal to negative 2 times 0 over 0 plus 1. And that's 0 over 1, which is y equals 0. So our y-intercept is also at 0. So that's the same point. Our x-intercept and our y-intercept are the same number. They're both at 0, 0. Okay. Now we look at the whole. Let's plug this negative 3 into our simplified function to see what the value is. So I get negative 2 times negative 3 divided by negative 3 plus 1. So that is going to give me, let's see, a 6 on top and a negative 2 on bottom, which becomes y equals negative 3. So I go to negative 3 on the x, and then I go to negative 3 on the y, and I get a whole. Okay, so now we've already got 1 point on either side of this vertical asymptote. So let's get a couple more by plugging in some values. Okay, so So our x and y. Okay, so let's do -2. Okay, so I'll plug in a -2 into the simplified function. F of -2 gives me -2 times -2 over -2 plus 1. I'm plugging this into this function right here, the simplified one. Okay, so that gives me 4 over -1, which is -4. So I get the point -2, -4. So -2, -4, there's one right there. Okay, and if we wanted, we could do one more. Let's do one over here at -4. Plug in a -4, so f of -4 gives me -2 times -4 over -4 plus 1. That gives me 8 over -3, which is like -2 and a third equals -2 and 1/3. Okay, so if I go over here -4, it's going to be, here's -2 and a third. It's going to be a little bit under that line because this line is -2, so it's a little down from that. So this graph is going to look like this. Make sure you have that hole still there. Don't fill it up. Okay, let's choose some points over here. Let's do 1. So I do f of 1. F of 1, remember I'm plugging into this function right here, -2x times x plus 1. So it's -2 times 1 over 1 plus 1, which is -2 over 2, which is -1. So I plug in a 1 and I get a -1. Okay, let's plug in a 2. That'll be our last one. Oh, I keep forgetting to put these points here. So that last one was -2 and a third, and this one was 1, -1. Okay, one last one, we'll do f of 2. So I'm going to plug in a 2 into the function. Okay, and that will give me -2 times 2 over 2 plus 1. I'm still plugging into this function right here. Okay, so that gives me -4 over 3. So -4 thirds. So -4 thirds is a little bit under -1. Okay, so it'll be like right here. Okay, so we know this portion of the graph looks like this. And that's it.